With every single achievement in the space, India is emerging as frontline space power of the world. ISRO, Indian Space Research Organization, DRDO, Defense Research and Development Organization, and Indian Air Force recently on 2nd April 2023 achieved a milestone by successfully conducting the reusable launch vehicle autonomous landing experiment at the Aeronautical Test Range, Chitradurga, Karnataka. This would make us competitive enough to compete with developed nations or even outperform them in future as it is comparatively economical. So in this video, we will understand what are these and their advantages over the existing launch vehicles. Rockets have powerful propulsion systems that generate huge amounts of energy required to lift heavy objects like satellites into space by overcoming the gravitational pull of the Earth. Rockets has mainly 4 parts such as payload system, guidance system, structure system and propulsion system. The payload system consists of the satellite under the protective casing. Satellites carry one or more instruments that do the scientific work for which they are sent into space. There are basically 3 types of satellites. They are polar, geostationary and geosynchronous satellites. Polar satellites orbit the Earth at their poles and are permanently stationed at the poles, while geostationary satellites orbit the Earth at equator and have same period of revolution as Earth. Geosynchronous satellites are the type of geostationary satellite, as the only difference lies in the fact that they are inclined at an angle to the equator. We will study satellites in detail in some other video. Coming back to our topic, we notice that launch vehicles or rockets become useless after the launch. Rockets' only job is to carry the satellites to their intended orbits and place them. Once the fuel of the rocket is exhausted, they detach from it and fall off, often burning off in the atmosphere due to air friction and is destroyed or becomes the space debris. So let's recall India's space journey of launch vehicles. It all began with SLV, which stands for Satellite Launch Vehicle and was the first generation launch vehicle developed by ISRO. Developed under the leadership of Dr. APJ Abdul Kalam, its first test was conducted in 1979, which although failed, became the stepping stone for the marvels to be achieved later by ISRO. In 1980, its second test was successful. 4-stage solid propellant was used in it. HTPB, hydroxyl terminated polybutadiene, and AP, ammonium perchlorate, were used as fuel here. It could carry 40 to 50 kg satellites up to lower Earth orbit. Rohini series were launched through it. ASLV, Augmented Satellite Launch Vehicle, followed SLV. It was a second generation launch vehicle with a 5-stage solid propellant. It could carry 140 to 150 kg satellites up to lower Earth orbit. SOROS, that means Stretched Rohini series satellites, were launched through it. They operated until the 1990s before the PSLV came into the scenario. Moving further, PSLV, Polar Satellite Launch Vehicle, was first launched in October 1994 and has been the most powerful vehicle to date. A third generation launch vehicle equipped with liquid stages and has 4 stages. The first stage is solid with 6 strap-on boosters, followed by liquid, solid, liquid stages. S139 solid stage and Vikas engine liquid stage are used in it. It was used in the Chandrayaan-1 in 2008 and MOM Mars Orbital Mission in 2013. PSLV is called the workhorse of the ISRO. It has variants like PSLV-CA, core alone, PSLV-G, ground, and PSLV-XL, extra large. It can carry payload of 1750 kg in sun-synchronous polar orbits up to the altitude of 600 km and a payload of 1425 kg up to geosynchronous transfer orbit. It takes about 3 months to assemble and costs around 200 crores. PSLV C-55 mission was launched successfully on 22nd April 2023, that is yesterday, with 2 Singaporean satellites, TEL-EOS-2 and Lumelite 4, which makes a total of 57 PSLV flights till today. Then comes GSLV, Geosynchronous Satellite Launch Vehicle, which is a much more powerful rocket and can carry heavier satellites deeper in space. This 4th generation launch vehicle has been in use since 2001. S200 engine, solid stage, Bikash engine, liquid stage, CE 7.5 and CE 20 engine, cryogenic stage. A total of 3 stages are used in this. This is used for launching different communication satellites. This takes about 4 months to assemble and costs up to 400 crores. Under this, GSLV Mk1 uses Russian cryogenic engine. It can carry 1.5 ton satellite up to GTO. In GSLV Mk2, CE 7.5 engine is used, which can carry 2.5 ton satellite up to GTO and 5 ton satellite up to lower Earth orbit. While GSLV Mk3 is a 3-stage heavy launch vehicle meant for heavier satellites. It can carry satellites weighing up to 4 tons in GTO and 10 tons in lower Earth orbits and uses an engine CE-20. It is nicknamed Bahubali. It was used in Chandrayaan-2, also called LVM-3 Launch Vehicle Mark III, and is chosen for the Gaganyaan mission. SSLV is the baby rocket of ISRO, known as Small Satellite Launch Vehicle, and offered cost-effective launch services for satellites up to 500 kg for 500 kilometers. It is meant to target rising global demand for the launch of small and micro satellites. Capable of multi-orbit drop-offs, can be assembled in merely 72 hours. It can be launched every week, cost of around 30 crores, and has 3 stages, solid propellant and a liquid stage. EOS-03 was launched using this. Azadi Sat, made by all school girls, was launched under this in the month of August 2022. However, it failed in the last stage, but was an achievement in its own. Then comes RLV-TD, Reusable Launch Vehicle Technology Demonstrator, as it had its first successful test flight in the year 2016. It uses scramjet engine. Only a small part of the rocket is destroyed during the mission and can re-enter the Earth's atmosphere like an airplane. We can save billions of dollars using this and can cut down the cost by 80%. Therefore, we can summarize by saying that SLV and ASLV belong to the history. PSLV and GSLV are currently in use, while SSLV and RLV holds futuristic prospects for all of us. Hope you found this video informative. For more such insights, keep watching and keep learning. Thank you for your time.